I wanted to take a quick look at what some people did. So here is problem 1 from room 1. They've added a random number, inserted that random number where the 3 was, and produced the answer, which is that number squared, which is great. So this is good. Looks good. I do want to. I did see some people had put this inside of quotation marks. That is allowed. It has some consequences in terms of what gets displayed when the correct answers are requested by the student after the answer due date. If you do this inside quotation marks, your answer will actually show exactly like this. It would have your number with 2 stars and a 2 as the correct answer. You might want to have it without the quotation marks like this, which would give you the result of doing the square as the correct answer. That'll have more of an issue. That'll become more of an issue when you use some of the restricted contexts that don't allow the student to produce certain kinds of answers. For example, if you wanted them to perform a computation, you wouldn't want them to be able to ask WeBWorK to perform that computation for them. And so you would want to give an answer that's in the form that they would be able to type, that doesn't have it in it. So something like this is nice. Problem 1, this is again the similar thing. You produce a random number, you give that random number in the math mode, and you change that number in the formula. That's quite nice. 2 does the same thing, but now we have 2 numbers. And of course, a factored form is an easy way to get the correct answer there. I do want to show one thing about this, however. If we look at that problem locally, room 1, view it. That was this one. If we look at that problem, looks perfectly fine. If we show the correct answers, again, students will be able to do this after the answer date. The correct answer is x minus 4 and x times x minus 1. And that's perfectly correct. It's a little awkward for viewing, and we might want to clean that up. We'll talk about that next week, some of the means by which you can get rid of things like double negatives and so forth. But for right now, this is perfectly fine. An alternative for people who wanted this to look nicer would have been to write it out, do the FOIL thing yourself and produce values that you would put into the formula that had the correct a squared plus ax squared plus bx plus c. We'll have worked out the values for those by hand and put them in as variables. But we'll look at some ways of improving the look of that output later on. Okay, so the last one I wanted to look at was the, I want to look at the 4th one, which was the average problem. Let's take a different room, see how they did. Okay, 3 random numbers, an average which they've actually made a math object out of it. That's great, that's perfectly fine. Said find the averages of these and put that as the answer. So that works out just right. So if you've done something along those lines, kudos to you. That those were very good answers to the problem. All right, then we will press on with more about PGML. Okay, we have just a few more slides to do with the presentation here. Okay, here's the next one. And so there's a little bit more in formatting that I wanted to talk about. The ones that we talked about so far, how to get math, how to get variables, and so on into this, those are sort of the very basic things that you need. But there are some other things you might like. One of them is things like lists or bullet lists or number lists. So numeric lists are created using a number followed by a dot and a space. And the numbering is automatic, so you don't have to number them consecutively. So here's a list, a line that starts with a 1 and a space or any number of 1 or 2 spaces. This starts an item, a list. And just as before, you can continue that list onto its next line. These will be joined together. This is the first item of the list. I don't have to put these in any kind of order. 1, 1, 1 produces 1, 2, 3 in the result. In fact, I could have started 3, 7, 14, and it would still have produced 1, 2, 3. It's just a pattern. And then additional atoms. Continuations can be indented like this one, which makes it easier to read. But if you're lazy, you don't actually have to indent the second one. And so this is part of the list. Again, a paragraph break ends the list, so this blank line ends the list, and a paragraph, another list following that starts the numbering over. You can include a paragraph break in an item by including the indenting here at this point. So that this indenting here, the fact that the paragraph break has the next paragraph starts indented means it's part of that, that item. So here, this one is part of the list. So you can have paragraph breaks that way. Alphabetical lists work similarly. You put letters and a dot or an open paren, put that paren in this case. Roman letters are using Roman numerals. Again, paragraph breaks end those. So here we get an alphabetical list, here a Roman numeral list. And again, what Roman numeral or what letter you use doesn't matter as long as it starts the line and has a dot or a parenthesis after it. That'll get you lists. You can get lists that are bullet lists using either a star or a plus or a zero or an O or a dash. I don't have a dash example here, but there's one a little bit later on. All these produce bullet lists. The star and the plus both produce, the star and the dash both produce the round bullet. The plus produces a square bullet. The O produces an open bullet. You can put paragraph breaks between your bullet items, and they'll be broken up and so forth. So these are ways of getting lists. If you want to have sublists, you indent them. So here is a numbered list, and the first item has a sublist that's a bulleted list. So you can get as fancy with this as you want. Of course, this is much more than what you probably will have in a problem, in a WeBWorK problem, but it's available to you if you need it. All right, headings. Oops, question? Yes. Oh, thanks. That's fine. So headings. There are 6 levels of headings, and they are produced by putting little hash marks on the front and back of the headings. So heading size 1 has 1 hash mark, heading size 2 has 2 hash marks, and so forth. So you get more nested the more these are. So here you get heading size 1, 2, 3, 4, 5, 6. And again, 2 separate lines get combined. So this is a heading that was written over 2 lines in the source code, but takes up whatever room it needs. A whole paragraph, again, you don't need to mark each line separately in the source. That will make 1 heading in the result. End the heading with 2 spaces to make a break. This one forces a line break within that heading, so 2 lines of heading. The trailing hashes are actually optional. You only need to start them out this way. And you can combine these things with things like centering or right justification or indenting or whatever. So here should be centered heading and a right justified heading. So this first one is centered because it's got the angled brackets at both ends. This one is right justified because it's being pushed over to the right from these ones on the left. So those are headings of different kinds. So if you need to have a problem that has several sections to it, you can put headings in there. You can also put ruler lines. A line that has just some dashes, at least 3 of them by itself, or some equal signs, produces a rule. So here is a ruler line right there. You can specify how wide the line is supposed to be. You can specify a percentage size if you want. So this is half of the available space. You can specify a width. This one here with the 2 inches and 10 pixels is taller, it was wider than these other ones. There are a bunch of ways of doing it. You can center them, you can right justify them. So these things all work that same way, but you can get rulers if you need them. Smart quotes, the double and single quotes act as smart quotes. So if you are using the one that's over by the carriage return on your keyboard, it will turn into the smart ones that are distinct at the left and the right. So even though this one is not in the source code, it is in the final. It does it inside, it properly handles things like punctuation around them. Here's one that's in the middle of the word. You get the correct smart version of that. Single quotes, they get turned into those things themselves. If you don't want them to be turned into it, you put a slash out in front. Slash is markdown, and therefore PGML's way of preventing a character from having its normal action. So putting a slash in here says use the good old dumb quotes on both of these two places. It will not treat them specially. So that's a quoting of the quotes. Special characters. I talked about this earlier on. Special characters that are used in HTML or in tech are things that traditionally you have to be careful about. If you put them into your text and you haven't taken care properly, they can either mess up the output on the screen in HTML or mess up the output in tech. But PGML takes care of that for you. So all the special characters escape themselves correctly. So just typing in all of these are special characters in HTML. Left angle brackets, right angle brackets, and ampersands are special in HTML, and the ampersand, the percent sign, the hats, the tildes, the hash marks, the braces, those are special in tech. But you can just type them in straight as you want to, and they'll come out being themselves in the text. So nothing special has to be treated. They don't have to be treated specially within PGML. A little bit more about these. The PGML special characters you'd have to think about. These are the open and closed square brackets, the stars and underscores and things like that that are used to tell PGML how to mark things up. If you wanted those to be displayed exactly as you had them originally, you have to escape them with the backslash. So this prevents this brackets underscores from being turned into an answer blank. That first slash prevents that from being interpreted by PGML as a blank, and we put it in as literally a left brackets and underscores. And this prevents the italic from being made into italics and leaves them as underscores. So you can prevent PGML from interpreting your things using a backslash. And of course, a backslash will produce a single backslash. Comments in PGML. Someone asked about the hash being a comment. Well, the hash is not a comment inside PGML. The way you have a comment in PGML is you put it inside square brackets with percent signs inside of it. So this particular piece of text gets removed. You say down here, this is removed. The text doesn't appear there. And you can comment out commands and other kind of things. So here's a piece of a command that maybe you haven't got right. You want to take it out so you can see the rest of it. You can comment that out. And you can nest the comments. So this comment goes all the way to the end here, even though there is a terminator here, because there's also an opening inside of that. So comments can be nested. We don't see any of that. So you can use this to comment out chunks of your PGML if you want to, if you're working on it and you haven't got it right yet, and you want to look at other parts of it. So, or if you want to put in comments saying why something is in there, you can do that. All right, so this is the table of contents for this set of talks. There are two other pages we mentioned briefly. One is this interactive lab, and one was the typeset lab. I want to show you this lab just briefly, because this is a place you can experiment with PGML, and there is a bunch of examples of things here. So these menus, are you able to see the menus? Okay, the menus here list topics like tech math. So here is a sample that uses inline math in tech, display style math in tech. Here is an indented equation, and here is a centered equation because of the centering around it. So if we process this, we'll see what the layout was. So here is inline, display math, an indented math, and a centered math. Now, because the word centered is there, this is not centered very easily, but if I get rid of the word there, that expression will be centered. So you can see what this looks like. That's how you get a centered equation on a line by itself. You put it inside the angle brackets like that. If you want to indent it, you do it this way. If you want it flush left, you don't indent it, and it'll be flush left, so forth. All right, so this is the place to play. There are, examples of all the different kinds of lists, examples of answers of various kinds. I haven't talked about math objects and things of that kind yet, so there are a bunch of these things we'll be doing next week. Here are some sample problems. So, for example, here's one that includes a graph that gets made on the fly, a numbered list, a way of inserting that graph, and there's the graph and the list of answers. So there's some sophisticated pieces in here. There are also references for all of the commands that you can have. So math, you can do tech, you can do display tech, you can do this parsed math, the display parsed math, and so forth. These interactive labs are going to be available all summer. Yeah, they'll probably be available for several years. So yeah, these things stick around. So this is a place to try things out. So for example, somebody said you couldn't get at the arrays. So let me just check that this actually you can. If we set an array to be let's make it be 5, 7, 8, 10, whatever. So here's an array. And we want to be able to get at it. You should be able to do a 2, for example, to get at the third entry in this array. So this should get me a 10, which it does. So you can certainly get at these things. If it's in math mode, somebody was saying there's a problem with that. So if I get x equals something in math mode, this should say x equals 10. And that also is true. So I'm not sure what the problem is that the person was having, but this should actually work.
David, the problem we were having was when the index of which element of the array we wanted was also a variable.
Okay, so let's say that we had $I is 2. We put $I here. Let's try that. Okay, so there's your issue. All right, so that's probably that. Let's try being a little sneaky about it here. There we go. Okay, so yeah, so that's true. Okay, I see what you're saying. There is it's picked up, in this case, this $I as a substitution that gets done before this other substitution. So what's actually getting done is A2, and A2 doesn't exist. So I bet if we had A2 out here, I don't know if this is going to work or not. Caught. Let's see if we get that and put this back in. It's an interesting situation. Yeah. Okay. So what you actually asked for here is a request to substitute the value of I into the expression at this point. That gets done first, and this is what you've actually asked for. So I cheated by putting spaces around it, which means that this is no longer the substitution command, because the space, the bracket has to go with the $sign directly. So interesting. So yeah, good point. Thank you. All right, so that's the interactive lab. The last one was the typeset lab. I've already talked a little bit about that. with the interactive PGML lab, note you don't need to say begin PGML and PGML here. Whatever is inside of here is a PGML block. It's not a full problem here. It's just a piece. And there's a little bit more to PGML that we'll talk about next week after we've had a chance to talk about math objects, because there's connections between the two. And I can't talk about those connections until you know the other half, which is the math objects part. So I want to do one last thing before I turn this back over to John, which is a number of people have asked about how you get to view the problems and hook them and be able to view a problem as you're editing it. So I want to mention that. So if we have there are several ways of getting at this. Let me just look at the local problems we've been editing here. So view these. So if you're looking at the library browser, these buttons at the right, this one on the that looks like a pencil is an edit button, and the one with the eye is a view button. So if you were viewing a problem like this, if it's in a problem set or out of the browser, you see a little edit to link at the bottom here. So that would let you edit that in a different editor. It's not the one in the file manager, it's the PG editor. And if you have made changes here, so that, let's say, if this is in that, right? So I've got some text that I've added here. I can view that file that I just edited in another window. It actually opens it in another tab, and it's got my edits in it. So it's possible to flip between the tabs, between these two places, and as soon as you've made edits, take action says make the file visible in the other tab. So that's another mechanism that you might have, that you might find more convenient than having to open up the tabs yourself. So there are a variety of ways you can go about editing and viewing the files, and this edit link at the bottom lets you get at the editor that has those other. We'll be talking more about that editor, I think, in the future, because you need to be able to know how to create your own files, and that's one of the places to do it. So I'm sure we're going to say a little bit more about that next time.